Hi, Mike Hartog here from Florida Drone Supply, and we are here in sunny Southwest Florida, just outside Fort Myers at the old Army Air Base, where we are here testing the L1 today. Now we're going to talk about the DJI Zenmuse L1, go over all of its features, and see what DJI says it can and cannot do. Then we're going to go over the workflow and actually go out and fly the aircraft and collect a data set that you guys can download off our website. Then we're going to talk about the point cloud and what you can do with that and what applications it'd be great for and how we would apply that point cloud using different software. Now, I know it's going to be a long video and I really apologize for that ahead of time. We'll put the timestamps down the bottom, and if the video is helpful to you, please hit that like button, subscribe to our channel so we can create more videos like this for you. All right, let's go ahead and get started with this is the L1. So go ahead and open that guy up here. Now we have the gimbal here, has the cover on it. This is a class 1 laser product, has the skyport here. I've already taken the cover off of it. And then it comes with the cleaning cloth as well as that activation card for the DJI TERRA. 6-month trial. That way you can start practicing those point clouds and develop that for your company. Now let's go ahead and jump into the computer here and let's talk about the features that DJI has for us. So if we go to the website here, you can see that DJI has the specifications here. They also have a wonderful promo video. It has the integrated Lidar module as well as a highly efficient 2 square kilometers coverage in a single flight. So you can get a wide swath with each flight, allowing you to do a large area very, very quickly. It has a highly accurate IMU and a point rate of 248,000 points per second and supports 3 returns. And a detection range of up to 450 meters. It is an IP54 protection level for water, and it has the point cloud live view. And the best feature of the L1 is not the things that they say here on the DJI website, but I think the best feature is that this is a simple system that goes from A to Z. You don't have to worry about complicated mounting methods. Effortlessly and seamlessly connects to the drone. You basically just take the Zenmuse L1, put it directly on the bottom, and it works perfectly to put together both visible and LiDAR. It enhances those 3D capabilities and lets you recreate everything just on one run. It's a Livox frame module, and it has a survey grade camera that's 20 megapixel. We can create these topographical maps with contour lines without a problem. Simply export your LAS file, then put it in a program of your liking to do the modifications and the editing. We also have terrain follow and flight paths. These are great features if you need to maintain that distance from the ground in a variable height environment. Now, if you're in mountainous terrain and you're doing search and rescue and you need to have that nighttime rescue situation so you can find a path to get to somebody, if you have the TERRA app on your controller, you can actually create these models in real time and determine what valleys you can navigate in order to get to the person you need to get to. This can be a great opportunity so you can decide how far apart the canyon is, if you can get an aircraft in there, or if you can get resources down that road. You can determine if that road is passable by one of your support vehicles without having to walk it ahead of time. With DJI TERRA, this basically changes the game, and you can create these point clouds for vertical structures. You can create these for ground surface. Doesn't matter, it's capable of handling both those. We're going to go ahead and update the aircraft here with the data cable. Now, you're going to want to make sure that when you're using that software, you're going to use the PC and you're going to use the Assistant 2 for Matrice. Now, when you do that, I like to use the C2C cable that it came with. It will work with the USB A to C, but I like to try to use those original DJI cables if possible, just because they have better connectivity and they work very well. When you update your controller, you do have to use the USB A port on the top, so the A to A cable that it came with, or you can use the USB C out of your computer to the USB-A on the top of the controller. That does work as well. Let's go ahead and make sure we get that updated. If you don't, you will get avionics errors We learned that the hard way out here today. Now that we have our firmware updated and we're 100% good to go both on the controller and the aircraft, we're going to go ahead and create that mission plan, get this thing up in the air and start doing some LiDAR. So now we're going to go ahead and create this mission flight. You click mission flight right there. You can either create a route by selecting on the screen and hitting mapping.
The home point has been updated. Please check it on the map.
And get our home point set from the aircraft just now. And what we'll do is we'll go in here and zoom in and then tap on the screen and create the grid that we want. We're not going to do that this time. We're going to go ahead and try to use a KML. So I'm going to go ahead and exit back out of that and not save that. And I'm going to show you guys how to import the KML by selecting KML import right there. Hit mapping, external storage, and I'm going to select this Buck1. Buck1 is the name of the KML that we are using out here today for all of our data sets. And you can see there's some information there from the aircraft in the area, telling us that we have no SD card in our Zenmuse L1. And you can see here's the size of our box right here. It's approximately 451 feet on the one side and 623 feet on the long side there, 529 on the bottom there. So you can kind of see basically of what area we're trying to map. The first thing I'm going to do is I'm going to go ahead and click edit. And let's go ahead and go through all the parameters of the mapping mission first. First thing we have here is Buck1, which is the name of our mission. We'll go ahead and leave that is for consistency. The second thing we have here is our actual sensor. I'm going to change that to the Zenmuse L1. And it has two cameras. I'm going to select the LiDAR mapping camera. And what that's going to do is change the flight path so that it has the proper spacing for the LiDAR mission. Now, it's going to tell you there the point cloud density that's expected at that altitude and that overlap and the ortho GSD. And it's going to have the option to turn the calibration flight on or off right there. We're going to go ahead and leave that on in this case. We're not going to use the terrain follow. We're going to turn that on and leave that. Now what that's going to do is make it do a little figure 8 as it takes off. And we're going to leave our altitude mode to relative to takeoff point. And the flight altitude, we're going to leave that at 197 feet. Ours is set at feet right now. And it says target surface to takeoff point. I'm going to set that back to 0. I can do that with a slider. Oh, I got it perfect. Okay. And set that right there to 0. Now the takeoff speed, I'm going to go ahead and leave that at 11. That's a fine speed for takeoff and moving over to the location. 11.8 miles per hour is going to get us a 5 meters per second. Now, 5 meters per second is actually pretty slow. And that's going to be nice for foliage and that kind of thing. We can actually go up much higher. 10 meters per second would not be impossible. The advanced settings here, you can see our side overlap defaults to 20. I'm going to go ahead and change this to 50 so we can get a lot more overlap on this mission. Now our course angle here is at 206. We could change this course angle, and when doing so, it's going to change our map there and show us, as you can see, the run that we're going to do. And I'm going to go ahead and we're going to move these lines right here and move our box down so that it's a lot narrower. There it is, 152 feet. That's just under 50 meters. All right, so there's our box there now. 164, it's a little bit more. Now with our course running linear like that along the path, that's going to make that a 529 foot run. We don't want to do that. So let's go ahead and put this back over here. And let's see if we turn that a little bit more. I put that in 0. Oh, no, too far. There we go. Now it's flying across there. Now our margin set to 0, even though it does have quite a bit of margin on both sides. We're going to go ahead and leave that set to 0. Now let's go ahead and go back to our payload settings. We're going to go ahead and look at the echo mode here. That is set to triple. That'll give us triple redundancies on that. And LiDAR sample rate is 160 kilohertz. And scan mode is set to repeat. All right, so let's leave that. And I'm going to turn the RGB coloring on. So that's on now at this time as well. And there's our longitude and latitude there at the bottom. Go ahead and just review those real quick, kind of skim over it, make sure altitude is good. There's one last verification of everything. and it looks good to me. Let's go ahead and go back. Since our aircraft is on, we are able to jump directly into the aircraft and look at all of its settings. We want to go ahead and make sure that we have, this one has enable flight modes is turned off. We can go ahead and leave that on or off, depending on how we want to handle it. I like to have mine turned on personally, and that's just for emergency purposes. I can take it out of an autonomous mode by putting it in tripod mode instantaneously with one click of a button. Just my personal preference. Return to home altitude right now is set to 328 feet. I'm going to go ahead and just leave that where it's at the time being. Maximum altitude is set for 394 feet, so just under the 400-foot limit. Our distance limit is turned off. If you do have that on, you're going to want to make sure that's out far enough to cover your entire area. I suggest leaving it turned off entirely. I'm going to check our sensor state. Now you see here that the IMU, one of the IMUs is a little bit off, but for the most part we're pretty good. I'll go probably ahead and do an IMU calibration before we take our flight. And there is the compass as well, just so I can make sure everything is perfect. And then RC signal lost. I always set this to return to home. That's up to you, but I always have mine set to return to home. And then the center of gravity auto calibration, that's something you can do whenever you change sensors, but you'll want to do that up in the air while you're flying and so forth. You can't do that at this time. Make sure your obstacle sensor can set on how you like it, and go through those settings and make sure those are all just the way you want it. Now let's go ahead and go down here to the RTK. Right now we have our RTK connected and it is converging. So once it is completely up, we want to make sure that our information is right, our latitude and longitude of the base station. Compare that to our units. And once we get that, we can also edit that if necessary to make sure that it is spot on a known point. All right, let's go ahead and get ready to do the flight. I'm going to go ahead and save this mission so that way it is saved. I'm going to do that IMU calibration, and once I get that done, we'll go through the procedures for actually flying the mission. LZ clear. All right, we're going to go ahead and climb up to operational altitude. I've got this currently in the FPV mode so I can see what's happening and see what's going on. And I'm going to go ahead and raise this up to my 200-foot height. At 200 feet, I can verify that I'm clear of all obstacles. Do my safety turn real quick. There we are, approaching 160, 170, 80, 190, right at 200. Check my horizon. I can go ahead and do a safety clearing turn. One full rotation at this point in time. Verify. Yep, everything looks good. Now I'm going to go ahead and switch over to the Zenmuse L1 sensor, and I'm going to go ahead and do this calibration flight. You can see up here in the top, right underneath where it says in-flight RTK, there's a little figure 8 there. That's going to be my calibration flight. All right, commencing calibration flight now, and start. Now if I need to stop at any point in time, the stop button's right there on the left. Now I'm going to go ahead and go back to my map screen here. I'm going to check and make sure my traffic is all good, verify that there's no airspace issues, no aircraft in the vicinity. I'm going to go ahead and hide that screen, and I'm going to hit the play button. That's going to go ahead and bring up the upload flight mission. I'm going to hit upload flight mission now on the bottom of the screen. Verifying return to home, all that is good. Everything's good on the screen. I'm going to go ahead and hit start.
Aircraft heading to the
And now the aircraft's going to head to that start point now. Once it gets to the start point, it's going to do an IMU calibration flight where it's going to go forward and backwards, and it's going to verify everything and do some more calibrations. All right, so now that it's doing its capture, we can use the camera mode here where you can see the entire screen of what it's capturing in the RGB. Or you can hit Lidar, and it will show you the Lidar point cloud as it's developing. Go back over here to the split screen view. You can actually see some of the items popping up on this side here. There's a little building there, it popped up right there. It's kind of neat to be able to see both at the same time and see the sidewalk and what have you. Okay, so now we're back at the office. We got the SD card, and I've actually already transferred this over to my C drive on a C temp folder. We're going to go ahead and take the data and put it into DJI TERRA so we can create the LAS point cloud, then we can later point process that more. All right, I'm going to click on New Mission. I'm going to click Lidar Point Cloud Processing. I'm going to go ahead and change the name here to Buck 1 so we're consistent with everything else we've done. Now, up in the upper right-hand corner, you're going to see here there's a little folder there. Click Add Folder. I'm going to go to My PC, Windows Drive, and the temp folder. And I'm going to go ahead and grab the LiDAR mission that's in here. I'm just going to grab one of the folders I have. Then I'm going to go ahead and look down the settings. The first one's going to ask me my point cloud density. I want to go ahead and leave that at high. Then it's going to ask for the output coordinate system. Now this is really important. You have to know what your output coordinate system is for your area. Now we're going to use the known coordinate system here. Click OK, yeah or yes. And I'm going to hit search. Now we're going to be in the WGS 84 UTM zone map. You're going to need to know which zone you're currently located in. In our case, we're in zone 17, and then it's 17N since we're in the northern hemisphere. So I'm going to go ahead and select that right here and click OK. Now, if you don't know where you are in the zone coordinate system, all you got to do is open up Internet Explorer, search UTM zone map, and it'll immediately pop up and it'll show you a map of the United States and show you how that is. Kind of like time zones. And you'll see that the far right side, we're in 17 North here in Florida. All right. Now, altitude settings, seeing as how we are in the United States, we're going to use this NAVD88 height feet US. Set that. If you do not know or you can't get that to process, you can leave this at default and then you can reproject it later. But if you can get it to process now at this time, it is best to do it originally. All right. Then we'll go ahead and click the back button here. Go ahead and check the rest of our stuff here, the parameters, make sure that that's set properly for our application. If you're doing a building facade, something like that, you'd want to go ahead and make sure that your point cloud effective distance is set to just beyond the building, so that way you're not getting a lot of stuff far off in the distance. In our situation, we flew at 200 feet, so I'm going to put this at about 75 meters, and that'll just help us get rid of some dirt and noise that isn't necessary. And I'm going to optimize the point cloud accuracy. Then I'm going to have the reconstruction outputs. I'm going to select this one, which I cannot unselect, and then go ahead and make sure the LAS is selected, since that's what we're going to need for post-processing. And I'm going to click Start Processing. Simple as that. It's going to go ahead and process. Then once it's finished processing, we can go back and do some annotations and measurements from the point cloud, or we can download that LAS file and upload that to someone who's going to post-process it. There are a number of companies that will post-process. We've got a meeting here with Rockrobotic in a few minutes. We're going to go ahead and send over the point cloud to them and then let them show you what they can do with their software with the LAS file. They can create ISO lines, all kinds of things can be done as far as classifying trees, vegetation, whatever needs to be done. They do all that in post. And they can give you that deliverable that you can give to your client. Before we send this off, now that we've got it processed, let's go ahead and look here what we can do without processing. We can click this Annotate and Measurement section right here. And that gives us the options, these four options up here. One, we can figure out the coordinate system here. We can take measurements. We can calculate area. And we can do volumetrics. So if we wanted to find out the area of a roof or something, we can zoom in on this individual roof. Then we can click right here. And then we can click on the screen. And we can create those volumetric lines. But we can do so much more in post-processing. So we're going to go ahead and send this over to Rockrobotic and upload the LAS file to them. The way we're going to do that is we're going to go back to the main menu here. And I'm going to go ahead and click on the file here. Click on this little export button right here. And then it's going to ask me how I want to export that. I'm going to go ahead and click OK. And then it's going to ask me where I want to save that. I'm going to go ahead and save that zip file in my C temp in the same folder that the data is in. And then it's going to go ahead and export that mission. All right? Let's go ahead and give them a call. All right, so we got a hold of our friends David and Harrison over here at Rockrobotic, and they're going to walk you through the LAS file now.
All right, so here's your data. This is the Buck One here project you shared with me here in the Rock Cloud. Now it looks like what you've done already is you uploaded that LES file, and here it is. And it looks pretty darn gorgeous to me. Those are some beautiful colors. But the first thing you did is you went ahead and you upload this data. You defined the CRS, it's the coordinate reference system. That's what you produced in TERRA. So I assume, let's see what you did here. Looks like you defined that data set in a UTM zone 17. This is great. This is exactly what you should be doing. So whenever you process that data with DJI TERRA, you should be selecting a UTM zone, whichever one you're in, and the WS84 reference ellipsoid here. So this is the correct datum and vertical projection. This is a big topic to discuss, and there's gonna be a lot more information that you can probably get. I have my YouTube channel, Indiana Drones, a bunch of information out there. It's a big part of surveying, and the Rock Cloud will handle all of that for you, but it's also just a big thing to understand because at the end of the day, it looks like you reprojected here into this NAD 83 Florida West US survey feet projection and the North American vertical datum of 1988. So whenever you're taking your data from the L1 and TERRA, it doesn't always, it's not the end of the story. TERRA is just getting that 3D colorized point cloud. So what you want to do is you want to be taking that data, reprojecting it into the correct projection that you need your deliverables to be in. And then the other thing is putting in ground control points. You can see these green dots here on the screen. We have ground control point 1. And so you uploaded some ground control points, which is great. That's awesome. That's definitely what you want to be doing here. And the idea with these is that you want to have these ground control points in your final projection. So right here, we're working in this NAD 83 Florida West. And so those ground control points are also in that projection. And you can see here, you can upload them, share them. Pretty simple. I'm getting a, but it looks like you uploaded a CSV of these GCPs. Awesome. And let's go ahead and zoom into this one right here. And we can just take a quick look. So that looks great. Now, one of the first things you want to do, because the end of the day is we want to be delivering contours on this data set. We want to be classifying the LiDAR data. So you're going to go ahead and select this quick lightning bolt tool, and you're going to use this auto-align GCP functionality. And so you can actually click this and then select a point, but you already did it. So I'm going to go ahead and just select another point right next to it. Boom. And we can go ahead and auto-align the GCP to 1. We can also select any one of your other GCPs, but I believe this one was 1. That is number 1. So we're going to go ahead and click Align. Boom. Now it actually just moved the whole data set to the GCP. One click. So that's how you're going to take your L1 data. You're going to upload it in the Rock Cloud. You're going to reproject that data. And then you're going to bring in those GCPs and align them. Now you know you have a aligned data set in the Rock Cloud, in the correct projection. And it's almost smooth sailing from here because this is kind of like the last step that you need to verify as a user. You want to look at the data set, make sure it looks good, align those GCPs, be in the correct projection, and then you're going to come over here to process, and you're going to order the Rock Surveyor, which is going to deliver you the ground classified LiDAR data set. It's going to give you the contours. You can also get a bunch of other features classified if you want, roads, you can do bridges, transmission lines, water. There's a lot of things you can do, as well as brake lines. So brake lines, for all those who don't know, it's whenever you're looking at like water bodies, or you're trying to do hydro flattening, or you want to do brake lines even on just curbs, top of curbs, back of curbs. So for instance, if you were to upload a bunch of points, bunch of shots you got, if you're a surveyor and you're getting shots on the back of curb, you can bring all those into the Rock Cloud, and when you order those brake lines, it takes all those points into account as well. So it's not just doing it on water bodies, it's also doing it on your uploaded points as well. So we're going to go ahead and order this and see what the results look like. So we already ordered it. There's a bunch of other things you can do in the Rock Cloud too. If you're in utilities, you can do full vegetation management, you can do power line classification, there's hydrology. Planimetrics is an awesome one. So getting full planimetrics done in the cloud is pretty dope. But for this one, we're going to do the Rock Surveyor. And now let's take a look at what those results look like right now. So I'm going to come over here. It looks like we've already ordered Rock Surveyor and it's already finished. So I'm going to go ahead and click on the, first of all, let's go to elevation view. I think that's just easier for me to see. So now we can see the vegetation, some of these buildings, and I'm going to click to here on the layers and just say show that ground only. So that is the ground classified LiDAR dataset as well as the contours. So now we have a complete topo, we have that surface, and the deliverables. We also have an accuracy report and digital elevation model. That is in a nutshell what the Rock Cloud is doing. We're going to be able to take your LiDAR data sets, you're going to be able to reproject them correctly into your correct projection, put ground control points in, align them, and then process the data to a final deliverable. In this case, we have contours, ground classified LiDAR data set, as well as a digital elevation model and an accuracy report.
If you guys have any questions, feel free to contact us here at Florida Drone Supply. We'll be more than happy to answer your questions or answer your comments. If you did like this video, go ahead and hit that like button. Subscribe if you want to find out more videos like this and watch those. And as always, God bless and safe flying.